Hi guys, welcome back to the shop. Hey, today I'm going to get on the Yamaha YSC3. I believe that's right. Yeah, YS3C. I just forgot about that one the other day when I was telling you what we've got yet to work on. And this one has been on hold for a long time. So what I did was I had been putting up so many boring videos, bore the cylinder type videos, that I thought people were getting bored with them, so I quit putting them up. So this one is one that, this is my own, so I just didn't want to do those for a while and put them up. So I thought, well, I'll go ahead and get this one done and I can get that thing put back together. We did a lot of work on that. We got it running. It actually ran pretty good. But when I bought that bike, it had no air cleaner on it. And I knew, you know, if you go back to the video, you can hear it. It's really ringy. And I got it tore down, and I think we looked at it, and it was pretty bad. And I've got a set of first over pistons, but I don't know whether that's going to clean it up. It might do one, but I'm not sure about the other one. So we'll just see what it looks like and see if I can get it to get it close enough to clean up that it'll work okay. There might be a little bit around the exhaust port, intake port that doesn't quite do it, but I just don't want to spend any more money on it and get 50 over pistons, and you know, I might be able to do it, so we'll just see. Anyhow, let me get you overhead here. We'll go through it a little bit and then we'll start setting it up to bore one of them. All right, I was just kind of checking this out real quick, and I've got one that's going to clean up probably no problem, and the other one's pretty iffy. I've got a set of 25 over pistons, 0.25, and this one is the one I think is the worst. You know, it goes down to just past the ring lands right now. And this one, if you take the other piston, it does the same. But you go to the other cylinder, and it won't even go in it. So this one here is definitely going to have the bigger piston. And I think I'm going to be able to bore these with my 2-inch head, but I'm not real sure. I mean, it's just barely over 2. Yeah, 2.057. And that one's just about the same. And you know, this one here, like I say, is the worst. I'll get down around the just below the intake and above, actually the other way around, below the exhaust and above the intake. Yeah, see, that's 52 right there. So that leaves you about 5 thousandths around the ports. I probably wouldn't even attempt it on somebody else's cylinder, but I'm going to try it on mine. Let me just measure this one more time. And I'm going, I'm just looking for the biggest piston right now. This shouldn't be measured right here. They want you to measure that up a little higher on the skirt. So we're at 56 and a half. And on this one, yeah, believe it or not, that one's 1/1000ths bigger at 57. 57.3, so it's not quite 1/1000ths bigger, but that's the bigger one, so that's what we're going to use for number one. Okay, another thing you want to check on these is to make sure that you've got compatible rings. These are keystone, and you've got to make sure that you've got the keystone pistons and rings. And you can tell, you know, most people can just look at the top, but if you've never seen them before, if you put one on and it completely goes into the groove and is still loose, then you know it's a keystone. Because the top is got about a 7-degree angle on it, and if you've got a non-keystone ring and you try to put it on a keystone piston, it won't go in flush. It'll be sticking out. So you always want to do that. Normally they mark the pistons, and I don't see it here. That's why I wanted to check first. Because on a lot of the pistons they put a K on the top. These don't have that, so I wanted to make sure my piston and rings were compatible. So just put one on and see how it looks. So yeah, we've got I don't know if we're going to make it or not. We'll see. But another thing on these rings, you will see either an N or a T, and that will denote keystone. So it's usually on the left side, and these are so hard to read. Usually you can take a pencil and kind of highlight over the top of it. Sometimes you can see it then. I can. You know, you can just see it. Sometimes you have to kind of wipe that off with your finger, and that even made it better for me. I doubt that you're seeing that. I've got my big magnifier out here, and I doubt that you'll be able to see it. But it sure helps me. These both have ends on them, so they are keystone. And if you take the same rings and you try to put them in this way to check them, they will not go in there. See how much they're sticking out? Either groove. You've got to put them on in order to see that they're fitting properly. Okay, let me move this back a little bit. And let's take a look at one of these. I got my, you can see that these are, at the time, these were a new thing to have these 5-port cylinders. And you know, you can see the long finger ports. It's supposed to help scavenging. And those, of course, meet up with the ports here in the pistons. They go all the way through. was a pretty cool idea at the time. I don't know whether it really worked, but they always seemed like they ran pretty strong to me. Okay, and much more of the same over here. I just don't know whether I'm going to get it to clean up, but we do have a thousandths, about a thousandths and a half clearance, so we've got a little bit more that we can go on there. So hopefully, you know, I've got about 7 on this one, and let's see, that's this one, I believe. Yeah, see, that starts in there. This one, it almost goes to the first ringland, but this one, it goes all the way past the second one. So we've got about 5 thousandths, and then you add 6.5 for the clearance. You know, if we're lucky, we might make it. We'll see what it looks like. If it's just isn't going to do it by a lot, I'll probably have to go ahead and see if I can find some 0.5 millimeter over. But we're going to go ahead and give the worst one a try first. Thanks, guys. Don't forget the thumbs up. Okay, that's pretty close. Let's fire this thing up and see if we can get a little closer than that. Okay. I think we're just about as close as we're going to get here. There we go. And we'll go ahead and lock everything down here. And I don't know whether you'll be able to see it or not, but at least we'll go ahead and zero it out on the DRO. And we'll have to do a little bit more when we get the test indicator in place. So let me get that swapped out now. Okay, zeroed out back there. I'm not sure whether you're seeing it or not. I'll get you a little different angle. I think you can see it there now. So we'll move it around, and we're zero here, and we're working here. So we've got this is a 15 thousandths indicator, and I'm preloaded, so only got about 5 there to go. So we're 0 on the back, 0 on the front, 0 on the side, and 0 on the other side. So that's pretty good. We'll go with that. And then we go ahead and re-zero on the DRO. So that should be done at this point. Okay, like I say, this is going to be pretty tight. Looks like it will go, or right now it will anyway. Let me get this out a little bit further. It's a little too much. Okay. We'll take at the top here. Just barely hitting, kind of in the back here, I can hear it. That's kind of in the nowhere area. So I'm just going to drop it down a little bit more. No. Go down, check about midway. And then we'll go down to the bottom. I think you can hear it. It's hitting pretty hard on the back bottom. So I'll go ahead and tighten up because it'll change a little bit when I tighten this up. Yeah, got a little more pronounced noise there. A little on the back, even down further. It's really hitting hard on the side here when I get down to the bottom. Starts right here and then comes over. And it's actually hitting a little there too. So I need to move the cylinder back to try to center this up a little bit, just because of the wear. Let me see what I can do. Okay, I've gone through here, and I think I've got it kind of centered for the wear. Probably won't take much off, maybe just a little at the bottom here on this trip. I think I might add, I'm not getting anything there. Yeah, there is, right at the bottom, just a little. I'll leave it. It doesn't hurt to go through like that. Just takes a little time. I got lots of time. So I'm gonna send it through, and what we did was on the x-axis, we went minus 8 10,000ths. On the y-axis, we went plus 6 10,000ths. So we'll see what it does when we get through it the first time. Well, it's cutting most of the way around. A little bit in the front, not yet, but I imagine that will be the opposite in the bottom. That's generally how that is. So it doesn't look too bad at this point. It's really hard to see. This is just barely like 57 thousandths over 2 inches. So it's just, there's nothing to see once the boring head gets in there. Well, I think we're going to make it. I think you can see that it's pretty well cleaned up, except around the exhaust port over here. So even that would be not a game changer. Of course, it's, you still got it. We still got quite a bit. At least 2,000s. So let me do some measuring. Check it a couple times here. Yeah, 2.052, and our piston comes in at, we measure 10 millimeter from the bottom of the skirt. Okay, 2.057. So that's telling me we got 4,000s. No, actually closer to 5. And it's pretty clean already. I think it'll clean up around the exhaust port. And then, I think I'll take 2 and then reevaluate. But we're going to have about 1/1000 clearance. It can, a little bit less or a little bit more. It's okay. So I think we're going to make it. I am surprised. Let me get set up to go another 2. Well, not as bad as I thought, I don't think. I am surprised. That's usually how I do it, though, is with the wear, I usually have it hitting here and then at the very bottom on the backside. So if you just kind of split the difference between those two, you get about the same sound. I don't know, you can usually do pretty good by keeping the thing straight. Looks like it's still a little bit around the exhaust port. not cleaning up, but a lot more now than was. Sure glad I didn't have to bore that with the long boring bar. It just bores better this way. But you know, if you can't get the boring head in the cylinder, that's the only way, you know, the only option you have. Okay, we've still got a couple we can take, I think. Okay, yeah, we're at 250, 2.055, I think. Try it again. Four is what I got that time. Let's try it again. Yeah, 4. And we've got to go to 7, so we got 3. And there's still, oh, just a little bit around the intake and the exhaust. It would take, you know, if you had to stop now, you could do it with a hone. Looks like I'm running out of light here. I think you can see just a little bit top and bottom of the exhaust. All right, let's take another 2. Let's see, I think we cleaned up. Yep, close enough. A little bitty spot underneath the exhaust. The hone will get it. We may need one more trip. I don't know. We'll see here. Okay, that's 205.6. Yeah, 205.6, 2.056, and the piston's 7. So we're a thousandths away from being as big as the piston, and then a thousandths and a half or thereabouts clearance. So I think we'll stop. I just really didn't think it was going to clean up, but I'm glad it did. It was just kind of erratic the way it was. I mean, it's the normal wear front and back, but it just was kind of erratic where it looked around the ports and stuff. Okay. I'm happy with that. I think I'm in some carbon up here at the top. So I'm gonna, yeah, I really don't want to get down too much further. Maybe I can go a little bit. There. Looks pretty good. So we'll set our X and Y. Go ahead and lock our table and carriage. And get the gauge out of there. Yeah, looks pretty good. Just listening for that, for it to hit. Okay. This one's kind of like the other one was. I'm hitting at the top here and on the bottom over here. And that's kind of strange because it's not the way the wear is usually. I don't think you can see it down there, but on this side at the very bottom, that was the first trip through, just barely hit there. We got a little bit more here. It just barely hit there also at first trip. So we'll see what it turns out to be. You can actually see it there. It's hitting on the other side. The opposite side is this side, just barely, before it goes in. Okay, this is about 3/1000ths removed. You can see most of this side. It doesn't go quite to the bottom, just almost though. And then on the other side, it starts hitting just below the transfer port there. So the cylinder is way out around, but it's pretty well lined up. So you're cutting here at the top and over here at the bottom. So I think we'll take another 2 or 2/1000. Yeah, it's just starting to go in. It's about like the other one was, just starting it. So I'll probably do another 2, and that'll, I think, will just about, it won't clean it up, but it'll show complete coverage pretty much, just around the ports probably. Let's see what we can do. You can see there it's cutting more on the other side now at the top. So the front's cut now. A little more at the top on this side. Yeah. That worked good on the other one, so it looks like it's going to work on this one. Okay, still a little bit shy of hitting right here, and a little bit on the bottom of the intake. You can see that all but just a little bit here at the top on that side. This side's cleaned up all the way except a little bit down here around the S-port. And looks like we're good on the exhaust side. Maybe just a little bit around the port itself, right in here. Looks like on the bottom it's okay. So I would say that probably the next time I'll just about clean that up, I think. We've got quite a ways to go. Let me get a measurement on that. Okay, so I got 2.052. Remember, our piston is 2.057, so just about like the other one at this point, about 0.005 to go. So let's stick another 2 in and see where it ends up. All right, that's pretty well cleaned up. And I'm still getting about 0.004 needs to come out, so I'm going to go ahead and take another 2. Okay, good. We'll stop with that one. Okay, we'll get her honed here in a day or two. We're about 1.4 there. That's just about where we need to be. I'm going to put another 10th in. I don't like them quite that tight. I'll shoot closer to 1.5. That should do it. Thanks, guys. Don't forget the thumbs up. Okay, let's take a look at it here. Okay, and what did we end up with? Get you up here just a little bit further. Okay, right at 1.5. Got to watch this on the bottom. You see we've got a shorter one here. This is the longer one. I need the longer one to where the rollers are on my gauge. Otherwise it'll give me an erroneous entry reading. Okay, and right at 1.5 thousandths. They say 1.2 to 1.3, but that's just a little close. I like to set them up. The smaller ones, you can get by with that, you know, up to, you know, like your 90 twins, your 100 twins, those type of machines. They're even set closer than that. I think they're 1.1 to 1.3 or something like that. But you got to be realistic about it. You know, that is always when you have perfect conditions, and you just never know what you're going to end up with here. But I'm real happy with this. It completely cleaned up. Let me grab the other one real quick. Both of them did. Okay, so the next thing I need to do is do the chamfer. So I'll go in here. These are really sharp. So we'll chamfer these up, and then we'll go back and do a final 400 grit hone on it. But we've got to get it chamfered first, and then we'll press on with that. Okay, those are kind of hard to get, those S ports, but I think we got them. Your best gauge is your finger. Just put that in there and move it up and down, and if something feels sharp, you need to take care of that. But this feels good. Even the S ports. Deburr that a little bit at the top there. Next thing we'll do is check our surface there for flatness. Okay, then quick cleanup from the chamfering. And then quick ball hone both ways. That takes care of the sides of the ports, and also gives you a bit of a plateau hone. Get rid of all those filings from the chamfering process. Just the weight of the cylinder. And yeah, that's not going to take too much. And we'll take care of our heads too while we got the surface plate out. Yeah, it looks good. Okay, give these rings a check. Okay, these are supposed to be 0.15 to 0.35 millimeters, so 6 to 14 thousandths. Okay, I'm good at 13 on that one. It looks like 13 will work on that one too. So we're within there. Really, the most important thing about your ring gap is the minimum. You need to have at least that to keep the rings from going completely together and jamming when it heats up. So you really want to make sure you've got at least 6. These things always have, they're always to the max or over the max. And that's okay to a point. You know, you don't want 1/4 of an inch or something like that, but as long as you've got your 6 thousandths, you're good to go on your ring gap. I've just never seen them that, you know, they may be in the middle there somewhere, but they're usually going to be on the far side as far as the reading goes. I've already checked the other side, and I've got this side. Right here was my number 1. This piston is just a little bit bigger, so it goes to this the little bit larger cylinder. Okay, and again on your final cleaning of your cylinders, I've had a lot of people that don't catch the whole thing with the automatic transmission fluid, and I try to repeat it about every time. What I use for that final clean is automatic transmission fluid, and it doesn't matter which one or what kind. This is what you're getting. And the reason for the ATF is the fact that it is a very, very high detergent oil. They use that for a reason. And what I do is I just keep wiping with a fresh area on my rag, fresh oil, until I don't get any of this black anymore. So I'll just keep after it with another portion of the rag there, some more oil. When it comes out red and white, then I know that my cylinder is debris clean. See, it's getting better all the time. But when I get done, I try to wipe most of that out. It's not necessary to get it all out. But then I use whatever oil that I'm using in my motorcycle as to fit the pistons in. You know, whatever when you're getting ready to put it together, put that oil in it. In my case, I'll use Yamaha lube. That's what I use on all the injected bikes. You know, Suzuki doesn't make a oil anymore, so I use Yamaha lube in those. That's just what I use in everything. I even use it in my lawnmower, my little Lawn Boy lawnmower. So it's good for any 2-stroke. You know, they've made a lot of advances in oil. And you know, I'm not saying Yamalube's the best. I'm just saying that it's a economical oil. It's not terribly expensive, and it does a good job. I've never had any issues. It flows free from the tank, and I've just never had any issues. And it's pretty much low smoke. But that's the reason behind the ATF. It is a high detergent oil, higher detergent than normal motor oil. So that's why I use it, and it does a good job. If you want to use motor oil, nothing wrong with that. I just prefer this. Okay, now I use a dial bore gauge because I have one. I do a lot of cylinders, so it's just easier for me. And we've already gone through this, but I set it up to exactly the size of the piston. And then I can go in here and measure it, and I can see right there that I'm about 1 4/10,000 on that one. And 1 4/10,000 on that one. So it's just easier for me, but I do double check everything with a snap gauge. You pop those in, kind of put it at an angle on your intake exhaust side, tighten it up. Oops, got too much of an angle there. I can't hold on to the thing. I'm working around the camera here. Okay, so you get it at an angle like that, then you pull it toward you, like this. And that gives you the exact measurement of that hole. And then you can go ahead and get your measurement right here. And what I do when I'm using a snap gauge is I'll do it 3 times. Just so that I know I'm not getting an erroneous reading, or I might get a low one and a couple high ones or something like that. But whatever it is, that's what I do. Now, some people use feeler gauges. I don't recommend them. You got a couple problems with feeler gauge. Let me grab one. Okay, here's a feeler gauge. I'm just grabbing one. I don't care what size it is. This one happens to be 2.5 thousandths. But, you know, people put those in the bore and then push the piston down and try to get that proper feel. But the problem is on these smaller engines is you've got to take into account the thickness, the width of these things. When I'm measuring with a snap gauge, these are they're rounded on these ends, same as the bore gauge. There's actually a ball bearing here, and then you've got, you know, your little rollers on the backside. But you're measuring a pinpoint, and when you do this with a feeler gauge, you're taking up a lot more space. Now, a feeler gauge on a 4-inch engine is a little bit different. A 4-inch bore on a car, it's different because you've got a lot bigger bore area. But with a small one like this, I just don't recommend feeler gauges. I mean, you can do what you want to do, but 9 times out of 10, if you use a feeler gauge to set these up, your clearance is way too wide when you're done. See, this just happens to be a 2.5 thousandths one right here. Let me see if I've got one here that's, I don't know whether I've even got any that small. Oh, there's a 1.5 thou. See, that's close to what I'm dealing with here. But see, I'm still, you know, it's too tight here. So if I continued on until I got the proper feel for that, then I would be way too big on my clearance. See, I've got these set up at, I think one of them's 1.4 and the other one's 1.5. And this is a 1.5 feeler gauge, but it's not dropping through there. It's actually holding it up. And that's because of how wide it is. Now you might be able to, if you stripped them, made them a lot thinner, you could probably get a pretty close feel for it. But there again, I don't recommend it. But you can do what you want to do. But that's why I don't do it. I would rather use a feeler or a snap gauge and a micrometer, because you're going to get a awesome measurement that way. And the bore gauge just works easy for me, especially while I'm boring the cylinder and honing it to the final fit, because with all the oil and all that stuff going on at the honing machine, I can still put that in there and just do a quick check. And I don't have to do this and then do this and then try to measure it. But once I get it close, then I go to my snap gauge and my micrometer. These are the main tools that you need. Now this is an import bore gauge, and these are very accurate. You've got the different extensions that go in it, and then you've got some fine tuning down here with washers that you can put in there too. So you set that up for your bore, just like the other one. And the thing with bore gauges is you're not measuring anything. All you're doing is you're comparing this measurement to this measurement. Once you get it set up so you can measure the width of the piston, and on these they happen to measure at the very they measure at 10 millimeter according to Suzuki. That's where you want to measure it at. That's approximate. Now on a Wiseco piston or something like that, an aftermarket type, you're going to take your measurement at the very bottom, because that theoretically is going to be your widest point. But Yamaha and Suzuki on these older machines, Kawasaki I think also, but I just don't do enough of them to remember. I would have to look. But Suzuki and Yamaha both will tell you exactly where to measure the piston at if you're using an OEM piston. If not, you need to go by what the manufacturer tells you to do. And most of the time, they're not going to tell you. They're just going to assume that you know to measure the widest point, and that's going to be on the bottom of theirs. So anyhow, nothing wrong with these dial bore gauges. The biggest thing is you're going to set them up using a micrometer. So this is what you need, this and this. And if you want to go this far, you can get into this type of a dial bore gauge very economically. and just learn how to set it up and you're good to go. The one I use, it's got its own setup piece of equipment, and it has like a thimble on it like you do on a micrometer, so it sets up the same way as a mic does. But this is what most people use, one like this, and nothing wrong with them at all. And you don't need it. This and this will get the job done, and it'll get it done well. All right, let's just kind of go over the hone real quick. When you're boring a cylinder, this kind of hone will not work for you to fit the piston. It just doesn't take enough out, and there's no way for it to maintain a round hole. Same with this type of hone. This right here will destroy one of these two-stroke cylinders because it will grab a port and just tear the crap out of the whole inside of your cylinder. So do not use one of these. These things are good maybe for a four-stroke where you're just wanting to deglaze it. Same with this. As you saw when I was, after I did the chamfering, I used a ball hone. I went this way, and then I went this way. And that will get the sides of your ports. They're just very difficult to get to with your grinder. And I usually just do the tops and bottoms. Then I go back through, hit it with this both directions. Just maybe 5 revolutions left, 5 revolutions right, and I'm done. Now this is what you use to fit a piston. These are, you've got a double hone here, double hone over here, and then you've got these, what do they call these things? Guides. They keep you out of the ports. This here, they call it a keyway hone, and these here it keeps everything centered in there. Now you want to use these as a set. These aluminum wipers, guides, whatever you want to call them, they're going to wear at the same rate as your stones. So if you put new stones in, you want to put new wipers in because these are no longer going to touch. But this is what they call a rigid hone, and it screws in and out, it expands, and this will maintain a round hole. But the only problem that I have with these is that it's only good for about 2.5 inches up to about 6 or 8, something like that. Use different sets of stones for bigger, but I don't need them. I've got 2 sets of stones for size-wise. I think the upper end is 3.3 up to like 4 inches or something like that. And I've got maybe 360 Yamaha, 400 Suzuki. Those up there are on the upper end where I use those. The rest of them are all done with this from 2.5 inches up. Now, on the smaller bores, this is what I use. Both of these are used on the machine, but this type here can be used with a drill. It's just a different setup here. But this here is for the smaller bores. You've got replaceable shoes here on the bottom so that you maintain your tolerances. And you've got a double set of stones here. You can get these longer with 3, 4, 5 stones. I don't need them for anything that I do. I've got a couple of 3-stone ones just because I couldn't find a 2-stone. But the stones, The guide, the shoes, all that stuff are still available from Sunnin, as are these. But that's I just kind of wanted to cover the hone issue. Just do not use this type at all on a two-stroke. These are limited to deglazing. If you're just going to put some rings in, that's all you need for that. But if you're trying to fit a piston and maintain a round hole, you want something like this. These are both rigid hones. Rigid meaning that you can control the size and the amount of expansion, which also means that you're controlling the amount of your cut. And you can also do that by using different stones. I usually start out with, it kind of depends. If I've got a long way to go, I'll start with a 150, then I'll go to a 280, and then finish up with a 400. Same on these, but generally I get it close enough when I'm boring, where I've only got maybe 2 or 2.5 thousandths to go. I start with a 280, finish up with a 400. Okay guys, that's just about it. I haven't done a boring video for a while, and I just thought I would get this one done. I covered it a little bit different than I usually do. So I've had a lot of people ask me about honing and that sort of thing, so I didn't include a lot of it here, but I tried to cover some of the equipment and whatnot. And like I say, if you got one of those spring-loaded 3-arm hones, do not hone these things. They will grab those ports, and you'll just destroy the inside of your cylinder. Especially if you've already got it bored, and then you have one of those in there and it launches on you. You've just destroyed what you've been trying to do. So do yourself a favor, don't use one of those on a two-stroke. Okay guys, there you have it. Boring, honing, piston fit. Yamaha CS3C, 1970 model. This thing has been on my rack for way too long, and I just need to get that put together. I don't like leaving things apart too long, and this has been up there probably 6 months, if not longer. I think the last thing on there was the flat tracker. Finally got it all done, and this one here we need to get put together anyway, put together also. And I don't know that we'll be able to do the whole thing next week. We should be able to get it together, I would think. Maybe not fired up. But we've had it running already, and so I think, the points are done, the carbs are pretty close, all that stuff. So it'll just be putting it back together, making sure the oil pump is up to speed. And we did that too, but I had some problems with the oil pump, so I went ahead and I replaced that with another one. I'm back to where I was. I think I've done some oil pump work on this bike, so go back to the playlist on the CS3C, and you can probably find it there. And that brings up a point too. I think a lot of people don't realize that playlists are set on YouTube for like a whole series, like videos. So anytime I get another bike or do another project, I name that project, and then when I post the video, I also post it under the playlist. So there's some of them. I think the machining and I forget what they call it, fabrication and machining, I think is the name of it. There's probably over 100 videos in that one. It's just odd different jobs. But then on every bike, there's another one. The CS3C, everything I've done to that machine will fall under that playlist. Same thing with you know, the Suzuki RM400 or whatever. That's just how it all works. So if you're looking for something for a 400 Suzuki and you don't think I've ever done it, go back to the playlist. It'll list all of them, and you can hunt there. But anyhow, it's hard for me to remember. I've got I don't know, 519 videos or something like that up there. So it's kind of hard for me to remember where particular things are. So that's why I put them in a playlist. But anyhow, hey, thanks for going along on the ride, guys. See you next video.